Okay, video 4. We'll start things on number 10. I've already sketched the picture. Now normally I won't be sketching the picture, but I wanted to illustrate kind of what's happening here for those of you who can't just see it with the numbers. So I've mapped it out as just a rough estimate of the graph. And for part A it says let's use LRAM. So the first thing I'm going to do, just again to illustrate, normally I would answer this question and not even bother drawing the picture. But I have my vertical and broke this into 10 units. And then I'm going to form rectangles. And again, the rectangle's going to be formed from the left side. So let's actually change colors here. Let's go, I don't know, let's go purplish. So the rectangle top for the first rectangle is at 0. The next one's at 12. The next one, 22. Okay, so there we go. And so now we can see that the area is equal to the area of 10 rectangles. And so each rectangle, again, has a width of 1 unit. So we've got 1 times the first height plus the second height plus the third, etc. So really all we're doing, if you'll notice, we're just adding up the values in the table. But make sure, so I just did 6, so that's this last one. I know it's 0, so it won't really matter if you screw up on here and include the 0. But in general, if your end doesn't end at 0 and you add the next one on, that would be extending off beyond 10. So we want to make sure not to include this last one. And so then my area, in this case, is just going to be the sum because we've got 1 times. If the units had been 10 or 100 or a half, then that's what would be represented here. I'm not going to find the answer to that. You can handle that. And then the same would be true of then the right. So this one says use, for part B, says use RRAM. So once again, what's that going to look like? I've got my rectangles. My regions are first partitioned. And then when I go to make my rectangles, now I'm going to start from the right side. And so I get my rectangles formed this way. So once again, we're just going to end up adding up all the values. And this time we use 10. So notice we're not using this first value. And again, it's 0, so if you accidentally use it, you're going to get the right answer. But it won't always be 0. Like, for example, say it started at 5, and you say you include the 5, then you're going to get it wrong. So this one's simply going to become area equals the width of each rectangle is still 1, so we factor that out. And then we add them up. Skip the first one. We've got 12 plus 22 plus 10 plus, you get the idea, all the way to the last one, which is 0. And then we add that up, and we've got our answer. And it should be the same answer in A and B, I would think, based on the math if you look at the numbers. Okay, let's move on. Okay, so now we get to number 12. It's essentially the same question, just with different values. So we're driving on a dirt road. To find out how long the road is, you record the car's velocity every 10 seconds. Results are in the table. Velocity was converted from miles per hour into feet per second. So estimate the length of the road by averaging LRAM and RRAM. Okay. So if I'm going to use LRAM on number 12, first thing I'm going to do is realize, again, I'm doing how many rectangles here? 10-second intervals, so what is that? It's going to be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, be 12 intervals. Actually, be 11 intervals. 11 rectangles. Okay, so what that means is, and frankly it doesn't really matter how many rectangles there are, we know that the width of each rectangle is going to be 10 seconds. So we know that the area equals 10 times, and then since I'm using LRAM, I'll start and use the left value. So I'm going to do 0 plus 44 plus 15 plus 35. I'm not going to write these all down. Plus, skip ahead to the last few, which would be plus 44 plus 30, but not 35. Because again, if I bothered to sketch this picture out, the last value here is 35. So if I'm forming rectangles from the left, this last rectangle is covered by the value of 30. 35 would extend beyond my region if that's 120, and I wouldn't want to use it. So I leave that last one out. So I add them all up and multiply by 10, and that'll be my answer. So then I can quickly get the answer to RRAM by repeating all the math. Area equals 10 times, this time I don't want to include the first value, which was 0. So I'm going to do 144 plus 15 plus 35 plus all the way to the end, including 44 and 30, and this time I will use the 35. And that will give me my answer to RRAM, and then it just asks me to average those. Your units here will be in feet, and so if you want to convert that into miles, if you know, it says what's the distance of the road. Normally we don't measure road distances in feet, but I'm not too concerned about that. Problem 13, pretty much the same question to start. Part A, use rectangles to estimate how far the car travels. Notice it doesn't say use left, use right, so I'm just going to use left and call it good. So the width of these rectangles, let's see, has been converted, they say, from miles per hour. Actually, they haven't converted it, so that's in miles per hour, but they've only recorded the velocity for 36 seconds. So they've broken the seconds into how much of an hour that is. And so on 13, if I'm going to use LRAM to answer the question, then the width of each interval would be the spacing here, which is simply going to be 0.001 each time. That's how much it changes. And then the left side is going to be first rectangle to have a height of 0, 40, 62, 82, 96, 108, 116. I think I'll go ahead and answer this one all the way. 125. And I almost made a mistake because I almost added 142. But once again, that would be too much. So let me grab my calculator, because why not? So I've got 40. I don't need to read these to you. I'm going to be silent. So I did that really quick. It looks like I got an answer of 0.001 times 898, which multiply times 0.001, get an answer that should be obvious of 0.898. So it looks like I have traveled approximately 0.898 miles. So in 36 seconds, I'm going from 0 miles per hour up to 142 miles an hour. In that amount of time, it'll travel about 0.898 miles. That's going to be an under approximation because, again, I'm accelerating, so this is an increasing function. So we could do the right instead. In fact, let's do that because it's really easy. So here's LRAM's answer. RRAM's answer, simply take the value that we got here, 898, take away the first one, which is 0, and add in the last one. So I should get, for RRAM, 0.001 times 898 plus that last value. Let's try that again. Plus 142. So now my new total is 1,040 times, and I get 1.04 miles. So it seems pretty obvious the answer is about a mile. If I had more data, I could get more accurate. So there's your answer to part A. Then we go to part B, and it says roughly how long did it take the car to reach the halfway point? So if we take half of 898, we obviously get 449. So now the question is, how long did it take us to get to a total distance of 0.449 miles? So what that means is I kind of want to just start adding up the rectangles until I get to 0.449. So if I go the first second, the second second, third second, and I start adding them up, the value I'm looking for is 0.449. So if I pull the 0.001 out of that, I'm wondering how long it takes for this to equal 449. So that's going to be the 0 plus the 40 plus the 62. I'm at about 100 right now. Plus 82, so I'm about 180. Plus 96, I'm about 280. Do a little erasing here. 0.996 plus 108. Let's see what that gives us. 108 plus 96 plus 82 plus 62 plus 40. That's 388. So let's add in the next one. And that's 504. So going to here, that gets me 504. And again, that's going to be closer to the halfway point of my upper estimate. So it looks like my answer is, how long did it take me to go about half the distance? It took me 1 second, 2, 3, 4, 5, 6. So somewhere about 5.5, maybe 6 seconds to reach the halfway mark. How fast was the car going about then? So at the 5.5 to 6 second mark, looking at the table, oh, hold on a second. I said that those were seconds. That's not really seconds, is it? Because this is broken up into 36 seconds. Now the total is 36 seconds. And so we divided it up into, looks like 10 regions. So each region is about 3.6 seconds. So it looks like maybe about 5.5-ish is what we were kind of estimating, times each of those 0.001 would be should be 3.6 seconds, unless I'm thinking this through a little bit wrong. And so that looks like about 19.8. I'm worried about the length of this video, so I'm not going to overthink this. If that's not quite accurate, then I've just messed up the, what each of those times corresponds to. But I'm going to go ahead and hope that I am right there. Okay, then we're going to end this video. Let's see how much we have left. We have 3 problems left. Okay. So we'll pick that up in the next video.